Gorley. I got Haley Carter, but not Haley Gorley. Okay. All right. Let's see. I got -41 with a question mark, and you are right. Samantha, give yourself a pat on the back. Rebecca, give yourself a pat on the back. Adeline, give yourself a pat on the back. We got some good job here. Bella, Max, looking good. Close, Taven. Okay. Do you see subtraction? Okay, Bella shook her head yes. We get rid of subtraction by adding the opposite. So we are going to, let's get my pen to work, okay? We're going to keep the first number, and we're going to change this to addition, and then we're going to take the opposite. We're going to change this to addition, take the opposite of -32, which is +32. This is already addition, so we're going to leave it alone. Now I'm going to look at all my positive numbers. So 18 is positive and 32 is positive. So I'm going to go ahead and add those two together because when the signs are the same, we get to add them together. So I got 50. Then I have -35 and -56. So those signs are the same. So I'm going to add those together. 11, that's 9. So now I'm going to add those two together instead of trying to do 4 of them. Okay, so are there more negatives or more positives? Well, let's think about a number line. Here's 0. I'm going +50, which is going to take me here. Then this negative sign is going to throw me this way. And I'm going to go over to here, to something over here. So is my answer going to be positive or negative? Waiting.
Negative.
Thank you. And 91 minus 50 is 41. Okay, this is where our subtraction happened. That's the canceling. Okay? So those of you that got it wrong, pat your brain because you just grew it. You learned something, I hope. Okay? We're going to keep working on these till we get good at them. That's what we do. Let me turn the light on. Oh, there's Omar. All right. So today we are doing Unit 1, Lesson 4. We're going to continue looking at our scale copies. All right. So this says, what do you notice about corresponding distances between these polygons? Okay, corresponding distances, improvement mode so it'll be bigger. Corresponding distances are where we have a distance, but we don't have a line drawn. It's not one of the sides or the edges of the polygon. So this is a distance. What corresponds on the copy to BF?
Are you sharing your screen?
Did it not share? All right.
No.
No. That would be why we got a problem. I was wondering why it didn't work. Thank you for telling me. Now can you see my screen? Yes?
Yes.
It's loading.
Okay. All right. There we go. Now we're good. Okay, so let's start over again. So now that you can see it, here is BF. What corresponds to the distance BF on this big polygon?
TX.
TX, good. Now let's look at what happens to BF. BF is 2 units. TX is 1, 2, 3, 4, 5, 6 units. What's our scale factor? What did I do to 2 to get to 6? Wayne?
Multiplied by 3.
Multiplied by 3. So our scale factor, which is the multiplier, is 3. Well, let's test it. Let's do this distance right here, AD. That is 1, 2, 3. So what would we expect SV to be? 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It is. These are corresponding distances. So the scale factor affects the distances the same way it affects the sides. So if we look at side BC, that is 2. The corresponding side is DU, and that is 6. So it was multiplied by that same scale factor of 3. All right, we could measure this distance here. We could measure this distance here and here, and we would see that it was multiplied by the scale factor as well. All right. What do you notice about the corresponding angles between these polygons?
They're the same.
Rachel, what do you notice?
They're the same.
They're the same. So 42 corresponds to this angle right here, and they are exactly the same. If we change the angles, would that change the way a figure looked? Yes. That's why the angles have to stay, and we call it, when they're the same, we say they are congruent. So corresponding angles are congruent. So this 60-degree angle right here corresponds to this 60-degree angle right here in our copy. Okay? To be a scaled copy, first, corresponding segments, either the distance or the sides of the polygon, must be multiplied by the same number. What's that multiplier called? Go ahead, you just raised your hand and I don't know your name. Let's see. Why isn't it showing me your names? Dark hair, why can't I remember your name? Laura? Last name's Laura?
Yeah.
Rebecca. Yeah.
Rebecca.
Okay, Rebecca. I'm going to learn them eventually.
The scaled factor.
The scale factor, the multiplier is our scaled factor. And then corresponding angles must be congruent. What does congruent mean? Bella, what's congruent mean?
The same.
The same measurement. All right? So let's look at these rectangles. Are these rectangles scaled copies? So let's look at the angles. Are corresponding angles congruent? Yes, they are, because they're all right angles, right? Right angle, 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 right angle. Okay, where the sides multiplied by the same thing. Well, 2 times what makes 1? Rachel?
2 times 2. 1 times 2 equals 2.
All right,
1
you're
4.
going this way, but I'm going this way. 2
Yeah, 1 4.
what makes 1? 2 times 1 half, right, Addie? 2 times what makes
A half.
a half? Half of 2 is 1, okay? Now, what's half of 3? Rebecca?
1.5.
So are these scaled copies of each other? Is this a scaled copy of the original? Max, you're shaking your head yes. 2 times 1/2 is 1. What's 3 times 1/2, Max? What's half of 3?
1.5.
1.5. This side is 2. Were they multiplied by the same number? No. So these are not scaled copies. All right? So corresponding distances or sides must be multiplied by the same scale factor, and corresponding angles are congruent. All right? Questions you have for me? All right, so you have activities to do. You have practice problems to do. And then because today is Friday, we are doing our evidence of learning for the week. So you have a short check-in to do, and then you're going to reflect on your learning and make a plan for next week's learning on the last Google slide. All right? That is all you have for today. So if
Thank you.
you
Miss
have
Laird?
questions,